All right. Hello, everyone. Good afternoon. Everyone is all awake after lunch. All right. I'm Sam Armani, SVP Business Development at Mimik Technology. Mimik is a hybrid edge cloud company out of Oakland, California, and Vancouver, Canada. I've spent the last decade of my work on Edge Cloud at Mimik. I'm also a governing board member on Linux Foundation LFH, and I've been engaged in open source projects through IBM Open Horizon and LFH. It's a pleasure to be here this afternoon to have a conversation on intermittent networks, technology tools and platforms that could potentially address some of the challenges with this, and also go over some of the real world examples. But before doing that, I would like our panelists to also introduce themselves. Hanen.
Hi, good afternoon. My name is Hanen Garcia. I'm Global Telco Solutions Manager at Red Hat. I have been in the industry for more than 20 years and collaborating on many open source projects, including Linux Foundation networking and Edge as well.
All right, thank you.
Hi everyone, I'm Hakan Sonmez. I'm a product strategy manager at IBM's Networking and Edge Computing business unit. I'm also a member of LFH governing board. And prior to IBM, I worked in telco industry for more than 10 years, including a role at Cisco Systems as a technical marketing engineer.
Hi everyone, my name is Moshe Shadmon, and I'm the founder and CEO of AnyLog. AnyLog is a decentralized network to manage data. It's a network of nodes that process IoT data in a completely automated way. And in addition, it allows users to interact with the data as if the data is hosted in the cloud, although the data remains and managed at the edge. Prior to AnyLog, I was a founder of a database company called ScaleDB. ScaleDB merged into a Soft, now it's Aviva. My background is always in building companies and products in the area of big data.
Wonderful, thank you. So we're living in this hyper-connected world. No matter where we go, we have all these connected gadgets and services that requires internet all the time. We're almost paralyzed without connectivity these days. And with the growth of all these connected devices that we have, we're becoming more and more dependent on always-on networks, which is not always the case. To just give you guys a fun example, I was in Spain recently and I was staying at a friend's home which was fully connected. Even the shower was connected. And I arrived there the first day, internet was down. So I could not get anything to work and I had to spend the whole day figuring out how to manually operate things. Another example is with the recent revolution in Iran that the first thing government did was to disconnect internet. That's for a different reason, not to allow protesters organize effectively and also not be able to let the rest of the world know what's happening. So it's clear that we need to address the challenges around intermittent connectivity and also minimize our dependence on the networks that may go down for various reasons, from network power outage, natural disasters, government interventions, and also challenging situations like in mines, in sparsely connected rural areas. And the very first thing that, of course, comes to mind is edge technology, how to basically bring some of the processing down to these end nodes and enable peer-to-peer connectivity. So my first question is for you, Moshe. AnyLog is a platform that manages the data on the edge. Can you please explain how your company, AnyLog, addresses some of the challenges with intermittent networks?
Yeah, Sam, as you said, the networking is a big issue. It's one of the challenges that are at the edge. Connectivity is not always there, and I'll just touch on 2 points which are important. The first one is a decentralization, meaning nodes could process the data independently of anything else. So we need to assume that manage data are able to process the data without dependency on peer nodes. So that's one aspect. The second aspect is because users and applications need access to the data, and since we know that connectivity is not always there, the solution or the approach that AnyLog has taken is that the data is replicated in multiple nodes, such that if we lose connectivity to a particular node, we could still interact and get the data that we need with one of the surviving nodes.
I see. Okay, so if one node goes down or one area goes down, you have a backup.
Yes, you
Kind
have
of
to build it
replica.
such that you assume that at a given point of time, something breaks, something
Right.
is not reachable. But for the applications, I mean, in the same way that we go to the cloud and we want the data to be there, and we trust the cloud infrastructure to do that, we're doing a similar thing. And the solution, by the way, is very similar to the solution in the cloud, which is we have multiple copies of the data, and there is a setup that is able to recognize which node is not running and direct the request for the data from a peer node which survives and is able to provide the data.
Correct. Yeah, it's all about bringing the cloud capability down to these devices in order to be able to do these things.
Exactly.
Right.
The
Okay.
same problem exists in the cloud. The only issue is that it's more stable,
Centralized
right?
and yeah.
It's more stable. It's less. I mean, the issue of something fails is less frequent at the cloud. But there also, if you look at the setup, you see copies of the data, and the same approach is doable also at the edge.
Very good. Thank you, Moshe. And Hakan, can you elaborate a little bit on that from the IBM perspective, what you guys are working on to address this?
Sure, definitely. So to address intermittent network challenges, first I want to talk about our key edge computing product, which is Open Horizon project under Linux Foundation umbrella. And some of you may be familiar with this product, but this is basically a solution, open source solution that does deployment and lifecycle management of containerized applications at scale at edge nodes. And as IBM, we contributed the source code to Linux Foundation a couple years ago. And we also have a commercial distribution of it under the name of IBM Edge Application Manager. And so I think the key design principle to achieve performance with intermittent networks is autonomy. And we designed Open Horizon under this autonomy principle. And what do I mean by that? Let me explain. So Open Horizon architecture has two main components. One is a management hub that runs in your private data center on your private cloud, which is the central part. And then the second component is Open Horizon edge agents, which run on your edge nodes in your edge devices or edge service, which is the distributed part. So I think, as Moshe has described, being decentralized actually enables your solution to work better, perform better with intermittent networks. And so to realize autonomy principle, we designed some features such as we follow a pull mechanism rather than a push. So the edge nodes pull containerized images from the central location instead of being pushed down from the central location. And basically, once the edge agents are provisioned by the management hub, they act autonomously. Most of the actions are triggered by the edge nodes rather than the management hub. And for example, when there is a device failure, a software failure, the edge nodes roll back to the previous working image. And with all this, and with regards to security, the edge agents has no listening ports, so which reduces the attack surface. So with all these features, it enables Open Horizon to work autonomously with minimal interaction with the management hub, which enables to perform in intermittent connections.
Perfect. Thanks, Hakan. And we of course like to hear more on the deployment side and use cases, which we're going to get into. But before that, Hanen, my question for you is, what do you think is the most common network failure, and how can we design more robust architectures in order to address challenges around intermittent connectivity?
That's a good question. So you mentioned already two big ones, right? Power outages and catastrophes, right? But beside that, the most common problems on issue that you see is misconfiguration, actual human error. We are either updating or just configuring new elements in the network, and sometimes things doesn't go according to plan, and you have issues on the network and you lose connectivity. Probably what you experience in Spain.
Yes.
And the other big issue as well is traffic spikes, right? You have congestion, so you have suddenly a big number of customers, subscribers reaching at the same time, asking for those network resources that are, of course, as much as we over-provision, this is how we usually tackle the issue, we over-provision the capacity to the last big spike we have in the past X months, right? And of course, this has been how most of the network has been provisioned so far. So more probably, and we haven't seen that already during the pandemic, right? During the pandemic, most of the people were at home, and even though the traffic have increased, you haven't seen so much of issues out there because there was already capacity provision already before that. Now, how we are addressing that in the past, as I say, over-provisioning and Excel spreadsheets, things are changing on how we are actually building networks. Nowadays, we are moving into a cloud-native matters, in the cloud-native way of building networks, and actually trying to address that kind of traffic spike in another way, creating microservices and distributing things so that the network can easily handle those traffic spikes. Of course, there is still the issue of misconfiguration, but for that, there is a lot of automation happening as well today in the networks. So all these tasks get automated from the very high layer, upper layers in the systems.
Got it. That's interesting, and it's in fact this is when it comes to the architecture. That's the area that we've been heavily focused on at Mimik, is how to architect the applications and solutions such that we can bring some of the cloud capability as part of the applications and enable microservices and APIs everywhere, including the front-end applications that are running on these devices, and be able to fully distribute the workload, and that's to address issues around intermittent connectivity, and on top of that, latency, cost, data privacy, and security. Now, again, back to you, Hanen. How more on the system side, how can microservices and APIs improve the reliability of the systems during such scenarios?
Absolutely, and this goes when I was answering before. Is I'm going to give an example, right? We are now almost of the mobile network are implemented 5G. 5G is a new generation of networks, and that new generation of network is building in a cloud-native infrastructure. Most of the core elements today are going to be building on microservices architectures. The 3GPP itself has specified the core network to have what we call it the SBA. Basically, is the network's element between them interact through APIs as well. And the same is happening on the radio access network. So everything is moving into a microservices architecture and, of course, an API world. And this is what we're seeing right now with the implementation with the 5G. That doesn't stop there, because the fixed access network is evolving as well at the same time as the cable network as well. And they are going on that cloud-native journey into transforming what they used to have into this new disaggregated world with microservices and APIs.
Got it. And how about the peer-to-peer? Anything in that? No?
So the peer-to-peer, so if you're looking into when you are further I will say it on the edge, okay? So you are officially out of the network part that is under control of the service provider. This is where other technologies come into picture. This is where you guys play in the house, right? The service provider is guaranteeing you the connectivity from that device that is in your house onto the internet. Now, providing the connectivity until the late step, this is where the technology still have to, come in and be more mature in that regard.
Yeah, makes sense. So we're seeing more and more importance around distributed applications, almost in every industry vertical, from manufacturing, transportation, telemedicine, where connectivity is required to be on all the time. Now, what are some of the, and this is for you to start with you, Hakan, what are some of the important and relevant use cases from your perspective that you guys been working on to address this?
Sure, definitely. And as you mentioned, Sam, I would like to give two examples, one from manufacturing and other from transportation. To start with manufacturing, and maybe Industry 4.0 in more general terms. So obviously it's a huge vertical for edge computing, and that's something we really, keep focus on. And it has a lot of use cases. However, I would say more than 80% of these use cases would require some kind of image processing and video analytics, and that's a use case that we address as IBM. And the specific use case we have a real-world example or a demo is visual inspection. And I believe some of you may have seen this during this morning's keynote speech. We have a collaboration project with Boston Dynamics and their famous robot dog called Spot. And so basically using Open Horizon and technology and IBM visual inspection technology, we are able to deploy containerized visual inspection software on robot dog. And this robot dog can tour the facility, the manufacturing floor or any operations facility to do inspection of enterprise assets, especially in places where human access is dangerous or purely difficult. And so that's a working prototype now that is waiting for commercial use case deployments. And the other real-world example I want to give is from transportation. I think all of us would agree that like self-driving cars, drones, and autonomous ships will be huge use cases for edge computing. I read a recent article that says a self-driving car will be generating 10 gigabytes of data per mile. And obviously you can't send all this data to your central network or to cloud. That will be impossible. So that's where you need edge computing. And the particular use case we did for transportation is actually an autonomous ship project called Mayflower Autonomous Ship, which you can Google to learn more about. But basically, I think for the first time in history, we enabled a autonomous ship with no human crew on board to cross the Atlantic Ocean, departing from UK and arriving at Canada, Halifax, Canada, in about 5 weeks earlier this year in June. And so this was a real important use case for Open Horizon and IBM AI applications. And I think it's a perfect example of intermittent networks, because obviously when you cross the Atlantic Ocean, you won't have reliable connectivity all those 5 weeks, which means you need to depend on your edge computing, edge applications. And I'll be happy to talk more about those use cases with anyone interested after this panel.
Very interesting. Thank you, Hakan. Yeah, when it comes to cameras, that's pretty much in every industry vertical these days. You have in hospital, inside manufacturing floor, production line monitoring to find, for instance, defects and kind of do the image processing on the device itself. We see that a lot in every vertical, and that seems to be very relevant. And the fact that cameras have a lot of processing power, that they are actually capable of doing some of these things locally, and instead of relying 100% on the cloud or other servers to do the processing on. Now, Moshe, I know you guys have been involved on few use cases, working on use cases that are related to this. If you can share with us a little bit on that, would be great as well.
Sure. So we are also seeing the usage of cameras where companies deploy AI on top of it. And one of the challenges there is that you're able to get some decisions on some decisions where the camera is deployed, but what's missing, and that's the piece that AnyLog is helping with, is to see unified view of the data, even if the data is not local on your node. An example would be traffic lights. We want to direct the traffic light based on AI that is running on different places. But in order to decide whether you direct the traffic left or right, you need to see what's going on not only on your node, but also on a peer node or a nearby junction. And this gets things to be complicated because companies are writing protocols where streetlights need to talk to each other, which is very complicated. What AnyLog does in that scenarios, you are able to query your peer data as if it is local data. So you could bring all the data that you need in order to make a decision to one point, and then you could make the decision that you need without building complex protocols or without centralizing the data, which takes away the real-time aspects.
100%.
To get the decisions in real time. So that's the approach that we're using in order to make the edge nodes, even though they are kind of isolated, we allow them to see all the relevant data. Each node is able to query not only the local data, but also data that exists on the nodes nearby, which has data which is needed to make the right decision.
That's very good, and that's an important one, smart city, and also V2V, V2X related applications, which is something that safety is at stake, and making real-time decisions with the lowest latency possible is of course the key, and edge is the only thing. Yeah, exactly. So the bypassing that extra going up and down is really is helpful. And also, the way I always think about this is that with the world of robotics, for instance, that you mentioned, I mean, these robots are gonna get smarter and smarter and eventually kind of work like a human. And just the way that we communicate is share knowledge with each other, and there's a central database that we always learn from. This is exactly what robotics is going to go to, that they need to be able to think and also share knowledge with other peers. At the same time, be connected to the cloud. So cloud is always going to be there. And Hanen, if you like to elaborate on the use cases side from Red Hat, that would be great.
So many use cases out there, so in different industries. So, but I want to highlight one that is actually a space exploration.
Yeah.
And this is where the limit of the network is, right? So it's pretty difficult to have the network over there. And this is one of the things that is kind of more into the research part. Right. And this is what we have put actually devices in the space, and we actually driving with Red Hat technologies in that perspective. But there is as well all these part of areas of the world that doesn't have direct connectivity as well. And there we have to provide connectivity in most different ways. Of course, the satellite technology is there as well. And that's some stuff that as well we are working on, trying to see how we can provide and support this kind of rural connectivity as well.
Oh, wow, that's fantastic. Thank you. Well, I don't know about you guys, but I learned a lot, and I'd like to thank our panelists. And we have just a few minutes left, so I'd like to open the floor to questions. If you guys have any questions from any of us, please go ahead. I see John is processing very. Yeah. Sure, the gentleman behind, yeah, please.
The spin on the theme is, what about slow networks? You know, we've all been on airplanes and find out things don't work quite the same when you're on really slow connection. I don't know that there's anything we can do at the network layer necessarily, a lot of it's up to the application development, but any thoughts on slow networks versus disconnect?
That's a great question. Now, any of you guys want to tackle that, and I can add a couple of things maybe.
Well, what I could say is that if you think about your network, I think you could partition it into segments, and each segment. So, for example, you get the airplane example. So inside the airplane, right, you have a network that will work well because it's your network. You've deployed it, and you could put whatever is needed there. The problem is taking the data while the airplane is moving or flying and bring it to some place which is outside your local network. And that's the reason to make things decentralized and independent and with no reliance on something that you know might not work. So that's the approach, and if you are able to do something like that, then you know that it would work. It would work because you control what you are able to control, and you've got layers of fallback if something doesn't work for you. So I think the key thing, especially if you look at the edge, and we know that slow networks is something that appears frequently, is to build it such that there is no reliance on something which is remote and you know might not work efficiently.
I think Hakan wants to.
I want to add to that, limited throughput problem. It's a more generic answer, but I really see this relationship with edge computing and cloud computing as almost like an optimization problem. You want to, and which means that in this throughput limit is a constraint that you have on this optimization problem. So you really need to decide what to process on edge and what to process on cloud accordingly, while minimizing the cost, and the cost you select maybe your monetary cost, or it can be your computing cost. So I think it ends up in the application design.
Okay, that's interesting on the application design. I can add to that, but I don't know if Hanen.
I will let you add to that.
Yeah. So this is an interesting example you gave with the in-flight experience. From the mimik point of view, in fact, we don't touch the network. We don't rely on it. So let's say you have all these devices that are connected to a router and there's absolutely no internet even available. We enable peer-to-peer knowledge sharing and streaming from the application point of view. So we enable this notion of service mesh, which is on top of the network and at application level. And applications, based on application policy, they can share knowledge and stream content without existing of connectivity in hyperlocal environments. Now, of course, if devices are in different countries, different locations, we still need the connectivity for the discovery piece to happen, but the streaming can still happen in a peer-to-peer fashion. So that's from the application architecture point of view. And did you want to add anything, or?
I think you did great on that one. I will take the topic, but in another direction.
Perfect. All right. Thank you so much. I think we're even over time. Thank you so much for attending this session, afternoon, last day. And I hope you enjoy the rest of today. And please ping us. You know how to find any of us if you have any further questions. All right. Have a good afternoon.
Thank you.